Welcome, Hornets, and thank you for joining me today. Today we're going to be reviewing finding solutions in degree mode for multiple angles. Now, be aware I currently have between 0 and 360, but this back number can change to anything, even the front number, so I can narrow my range or I can expand my range. I know, for example, some teachers might ask you to find between 0 degrees and 540 degrees, or 720, which would be 4 pi or 3 pi. So just be aware these values can change based upon your teacher's whim or the whim of the textbook. So when we're dealing with this, be aware that as we solve, I'm just going to be adding 1/2 to both sides using my law of equality. And you'll notice we're right there with the cosine of 3 theta, and it has to equal 1/2. Now I like to use the dummy variable alpha, and I let alpha equal 3 theta. Now this is important. You have to let whoever is looking at your work know what it is you're doing. And in that case, that might be me, your teacher, or it might be somebody else. So we're now going to be able to use it, having defined it, and the cosine of alpha is equal to 1/2. Now I'm looking at my reference angles and my unit circle. We know that cosine is going to be positive. Now, once again, I like to think about it in terms of my radians, so it's a little bit more difficult for me. Once again, dealing with calculus so much. So we're talking about a pi over 3 angle, which is the equivalent of a 60-degree angle. So I'm now looking at the first quadrant, and I'm looking at the fourth quadrant. And I'm then going to be saying to myself, well, if alpha is equal to my 60 degrees, I want to make sure I add my period, 360 degrees times k. In the fourth quadrant, we're looking at 360 minus 60 degrees, and my alpha is now going to be 300 degrees plus 360 degrees k. Now, once I've got that all set up, I'm going to go ahead and replace. Since I know that alpha is equal to 3 theta, I can then say 3 theta is equal to 60 degrees plus 360 degrees k. And 3 theta equals 300 degrees plus 360 degrees k. I'm now going to divide everything by 3 on both sides. See, I'm just dividing everything by 3. This is going to give me my thetas are going to be 20 degrees plus 120 degrees k. And theta equals 100 degrees plus 120 degrees k. I can now look at this by letting k equal 0, k equaling 1, and we always stop just before we get to 3. So that means that I'm going to have k equaling 0, 1, and 2. And that's going to happen for both of these. When k equals 0, all I have is 20 degrees. And for this one, 100 degrees. And those are my first two. I'm then going to let k equal 1 and add 120, which is going to give me 140 degrees. For this one, 220 degrees. Then I add k equaling 2 is adding another 120 degrees, and that's going to give me 260 degrees. Adding another 120 degrees on this part is going to give me 340 degrees. Notice that all of these angles are between 0 and 360. And those are the solutions. Now we can arrange them from least to greatest, depending upon what your teacher asks. However, these are the 6 angles that we have. Now, if we decided to change this to something like 540, I would add another 120. That would give me 380. And then if I added another 120, I would end up with 500. All 5 of those would be within 540 degrees. If I added another 120, that would give me 460. Then 580 would be too much. Okay? Notice we can change these numbers and keep adding the values of k until all of our values are between the domain that is given. Alrighty, Hornets. That was a review working in degree mode of finding multiple solutions with varying rotations or multiple rotations within our domain. I hope this has helped. Please remember, if you like this and you feel that it is helpful, please click like. And if not, feel free to give me suggestions and I'll see what I can do to improve. Thank you very much. Please be well. Cheers and have a fantastic evening. Bye-bye now.